My name is Erik Boere and I am a Field Applications Engineer at Apex Microtechnology. Since 2009, Apex has been involved in an ever-increasing number of applications of power op-amps in industrial inkjet printers. In response, we have developed new amplifier products dedicated to the industrial inkjet printing market. In this video I will discuss MP106, targeted at Fujifilm Dimatix Samba and derivative printheads, and MP204 for Ricoh GEN4 and GEN5 printheads. Both MP106 and MP204 are open frame amplifiers, which means they consist of surface mount technology on an insulated metal substrate or IMS. This concept ensures cost-effective, compact and thermally optimized designs. While MP106 is a single amplifier, MP204 is a 4-channel amplifier. Since Fujifilm Dimatix Samba printheads are driven with negative fire pulses, MP106 has been optimized to be powered by a single high current negative supply. The diagram shows there are more power supply voltage necessary. However, these allow the front end of the amplifier to overdrive the output stage so that it can be connected between ground and the aforementioned high current negative supply voltage. Also, forcing the output stage to swing wider mitigates power dissipation. During the rising and falling edges of the fire pulses for the inkjet printhead, the amplifier sources and sinks considerable currents. To provide for these currents and prevent feedback through the supplies, possibly leading to amplifier instabilities, it's important all supplies are adequately decoupled. This means that the plus and minus VB as well as the minus VS supply pins should be decoupled with a low ESR electrolytic capacitor of 10 microfarads per ampere of output current and a parallel X7R 1 microfarad ceramic capacitor to ground. There is a diode between minus VB and minus VS to ensure a proper power-up sequence. RC and CC are phase compensation components which are external. They aid in stabilizing the amplifier for large capacitive loads, such as represented by piezoelectric inkjet printheads. Typical values are 750 ohms and 220 picofarads. Two other output signal stabilizing external components are RN and CN, together called a snubber circuit. This snubber should typically consist of a 5 ohms resistor in series with a 22 nanofarads capacitor. A third stabilizing element is RISO, which isolates the capacitive load from the amplifier's output. A typical value for RISO is 0.1 ohms. Experienced op-amp users will miss an input and a feedback resistor to set the amplifier's gain. With MP106, these are internal and the amplifier's gain is fixed to minus 15 volts per volt if the gain pin is left open, or to minus 20 volts per volt if the gain pin is tied to ground. Finally, MP106 provides an analog output voltage which is proportional to the device's substrate temperature at the location of the output MOSFETs. This pin can be monitored for over temperatures. Please understand that there can be quite a time lag between output MOSFET junction temperatures reaching very high values and the V10 pin signaling such to the outside world. MP204 is a 4-channel amplifier. In this picture only one channel is shown. There are many similarities with the earlier shown typical MP106 application diagram, so I won't go over these. By the way, similar does not mean that the same component values can be used. Please check the datasheet for the appropriate component values. However, there are some distinct differences. Unlike MP106, MP204's amplifier channels are non-inverting. Unlike MP106, each MP204 channel has a current limit feature, the level of which can be set by means of an external current limiting resistor RLIM. Unlike MP106, plus and minus VB of MP204 only need to be decoupled to ground by means of a 0.1 to 1 microfarad ceramic capacitor. And unlike MP106, the amplifier gain, each channel, is fixed to 14 volts per volt. Now let's see how a discussed typical application circuit works in practice. I've built up the earlier shown circuit with MP106 using an EK40 evaluation kit. Instead of using a real piezoelectric inkjet printhead, which is rather breakable and very expensive, I have connected a 540 nanofarads capacitive load, which is about the same capacitance as a Samba printhead would represent when all its 2048 nozzles are driven. I have connected the V10 pin to a multimeter. The shown voltage doesn't make sense now as the amplifier is still unpowered. Later I'll show what happens after applying power and turning on an input signal. The input has been configured to get a 0 to minus 36 volt output signal. I have set the pulse repetition rate to 30 kHz, which is rather low for a Samba printhead, which can be driven more than 200 kHz. I am monitoring the input and output of the circuit by means of this oscilloscope. As you can see, the yellow trace shows the input signal. The blue trace, representing the output voltage, is a flat line at 0 volts, as there is no output signal yet. I'm using a current probe to monitor the output current, which will show up in green on the scope. Right now there is no output current flowing, so the current trace is flat at 0 amperes. The power supplies are set as follows. Minus Vs is minus 48 volts, minus Vb is minus 60 volts, plus Vb is plus 15 volts. Please note that the proper power-up sequence for MP106 is minus Vs, minus Vb and then plus Vb. Before turning the power on, let's first kill the input signal. Now let's turn the power back on and provide an input signal. The multimeter now shows a certain voltage. The present reading represents a temperature of 27 degrees Celsius or 81 degrees Fahrenheit, and it's rising. The scope now shows the input signal in yellow, as we have seen before, the output voltage in blue and the output current in green. The output pulse amplitude is, as predicted, around minus 36 volts. The output current is, as stated before, considerable at 26 amps. Please note that currents like that necessitate a very careful PCB layout. Note that the minus Vs power supply's output current reading is not 26 amps. This is because the amplifier's output current is drawn from the decoupling capacitors and the power supply's current meter reading is average, not peak. In today's video, we have discussed the excellent new Apex products to drive today's popular piezoelectric inkjet printheads. Using Apex MP106 and MP204 can save you a lot of design time, as these amplifiers are available off the shelf and with documented performance specifications. With MP106 and MP204, there's no need to go through power analog design trouble. Apex has done that for you. For application help, please do not hesitate to contact myself or my fellow field applications engineers. Thank you for watching.